the central measures of tendency, which there are three of them. There is the mean, okay, then there is the mode, then there is the median. So like we saw that the mean, it is actually a good representation of a measure of central tendency. So these measures of central tendency, they are simply numbers that are used. One single number is used to actually represent a lot of numbers, okay? And the mean, like we said, you can have let's say these numbers. I'm just making them up, these numbers here. You can find the average or the mean of all these four numbers, and that average or mean, it will just be one number, but it's going to represent all these numbers. So that is the purpose of all these central measures of tendency. So the mode, the mean, and the median, they are used for the same reason, to represent a large data set of numbers. So for the mean, just to do a bit of a recap, for the mean, we said that if you're given numbers like this, okay, if you're given numbers like this, what do? You simply add the numbers and then divide that by how many the numbers are. So here is just the sum of all data values dividing by the number of the data values. So this is ungrouped data. This is for ungrouped data. So when the data is not grouped, this is what you do. So if it is ungrouped data, this is the formula. Mean is equal to sum of all data values over the number of data values. But then if the data is grouped, this is where we use this formula. So I said we could simplify it, this formula, like mean or x bar, summation of f of x over summation fi, okay. Then we said for this particular one here, we needed to come up with a frequency table, and the frequency table is just showing how frequent these numbers, which ones were recorded the most, okay. So here we find out that 4.0 was recorded 4 times, so it is the number that had. Yes, madam.
Are you recording?
Yes, I'm recording.
Oh, okay.
Yes, okay. So here we said that 4.0 was the number that at the highest frequency. So if you arrange these numbers, this being the least number to the highest number, arrange them like this, then you just start counting how many times the number showed up. So like for this case 4.0, we counted 4 times. That's the one with the highest frequency. Then here we just said you make another table and then you call it fx, and fx, you're multiplying f times x. You're multiplying this 3.3 times 1. This is what you do, okay. So at the end of the day, you come up with this table. You just add the total in here, the total in here, then you divide this over this to find the mean, okay. Then now the other thing now that we did was the one where you're given a range, okay. I'll just explain on this one. So how do you define the x values? You add the two numbers here, add them, then divide by 2. That is how you get your 12. This one is already given, okay. This one will be given. So if you are given these two values, so this column and this column are given, then you just need to come up with these 2 columns on your own. So this column here, column A, you add the two numbers and then divide them by 2. Similarly here, you add the two numbers, divide them by 2, you get 15. Then when you come up with these numbers, the ones for column B, you are then multiplying the ones in here and in here, so you multiply 11 times 12, that is how you get this. Then you continue doing it. 20 by 15, you get this. 30 by 18, you get this. Then when you are done, you add the total in here, also the total in here, and that will be the mean when you divide them. Okay, so now for geometric mean, I saw a slide here. So geometric mean here, this one is mostly used. I'm not really sure why he brought it up, maybe just for the sake of learning. So geometric mean is defined as the nth root of the product of n values, and that's the formula. Okay, but this one mostly applies for physical sciences, not biological sciences. Okay, but the formula here, let's say you are given the numbers 2, 4, 5. To find the geometric mean is very simple. You write geometric mean is equal to square root. You count the numbers 1, 2, 3. There are 3. You put 3 here, so that will be the cube root. Then you simply multiply the numbers. 2 by 4 by 5, and here the calculator will do everything. So geometric mean is not that difficult, but I don't know. So maybe in some cases, yeah, you can use it under biostatistics. There is also weighted mean, which also it's not so common in these biological sciences. Okay. So in situations, the observations may not have equal importance. In such situations, observations are given weights. Okay. When computing grade point average, okay, what we call GPA, the one that UNZA uses this system, grade point average. So when computing a grade point average, courses vary in their credit value. The number of credits must be used as the weights, and here you can come up with a weighted mean. So the weighted mean, you are simply multiplying, okay, the weight times the value over again to get the mean. So it's similar to calculating mean under the x bar. Okay, so but it's just one slide. I'm sure I just wanted you to know. But what is important on the mean, it's this one here. So the mean, like I said, it is a very good representative of a large data set. But the problem with the mean is that it is affected by what we call outliers. Okay, an outlier is an extremely high or low value. Okay, so we call these outliers. Okay, so now that is the disadvantage or the weakness that the mean has. So if there are outliers within the data set, the mean may not represent the data set in a balanced manner. Okay, because the outliers pull the mean in the direction of the outliers. Okay, so the mean does not represent the numbers properly. So look at the numbers that are here. So you can be asked which number is an outlier here. So it's easy to say that this one, it is an outlier because it's just an extremely high value compared to the other values. Okay, so the outlier is 202. So you compare all these numbers, they are within almost the same range, and then you get 202. So this is an example of an outlier. Okay, this is an example of an outlier. So now if you find the mean here, you find that this is ungrouped data, so finding the mean you just need to add everything and then divide by how many there are. You get 40.7. Now if you look at this 40.7, it's far away from these numbers, okay, because the mean should be closer to the numbers that are here, because you're using it to represent all the numbers in the data set. But if you look at 40.7, is very far away from the data set, okay. At least if we had maybe 20, or we had 21, 22, 24, we had 17, at least it could have fallen within the data set. But 4.77, and what has caused this, it is this extremely large value. These are what we call outliers. So now in this case, the mean may not be a good representation, okay. So now the mean takes into account all. Yes, madam.
Where is the 287 coming from?
Okay, so the 287 is the sum of all these numbers, right? All of them. When you add them, right?
When you add them.
Yes, yes. So when we add all these numbers, this is the 287. The 7 is when we count how many numbers are here. 1, 2, 3, 4, 5, 6, 7, eh? Then that's how you get the mean. Okay, so the mean is a good central measure of tendency. Actually, the mean is the best among the other central measures of tendency, and the reason is because it takes into account all observations in a sample, but it can be distorted by a single value, like here. So this value here has skewed up the mean, an outlier. So the advantage of the mean is that it takes into account all the values, but because of this, again, there's a weakness. If there is an outlier, the mean is distorted. So in these cases now, we are going to employ another measure of central tendency, such as the median, which can overcome. So the median is not affected by such things as outliers, okay. So always remember, under measures of central tendency, you have the mean, the median, and the mode. The mean is good because it represents all observations. That is if there is no outliers in the data set. But whenever there is an outlier, the median becomes more appropriate, okay. But if there are no outliers, it's better use the mean, because it will take account all observations in the sample. The median doesn't take into account all observations, because we just look at the middle number. Median simply means midway. So the median is a set of measurements defined to be the middle value when you arrange the numbers from lowest to highest. So look at these numbers here, 2, 9, 11, 5, 6. So if we arrange them here from lowest to highest, we arrange them, we'll start with 2, 5, 6, 9, 11. So we have arranged them. Then let's find the number which is in the middle. Okay, so you find that 6 is the number which is in the middle. So 6 is our median. Then just the number in the middle. So you see that this 6, it doesn't technically represent all the numbers that are here, because you haven't taken into account all the numbers. Okay, sorry. So the 6 does not really take into consideration all the numbers. You're just getting the middle number. Okay, but so you can see that this one is not going to be affected. Even if you had a very large number this side and another large number this side, you find that the middle point will still be 6. So the median is not affected by what? Outliers. So under what conditions do you use the median? When there are outliers, because it's not distorted in any way. Okay. So now let's look at another example. Here you've got the numbers. Let's arrange them. We'll start with 2, then 5, then 6. After 6 comes 9, then 11, and 27. So let's find the number in the middle. You cancel this, you cancel this, you cancel this, you cancel this. So here we remain with 2 numbers in the middle. Okay, so what do? Since there are 2 numbers, you simply add them, divide by 2. Okay, nine plus 6 is 15.
Why we divide?
Why we're dividing by
What?
why we're dividing by 2? So when you have like 2 numbers in the middle, so for the median, remember, for all measures of central tendency, the mean, the median, the mode, you simply need 1 number. So for the median, what the middle value? So on the middle value here, we find that there are 2 numbers. So you find the average of these 2 numbers by simply adding them, then dividing by 2. Okay. And the reason why we're dividing by 2 is because there are 2 numbers that are on the middle, but you only need 1, so you do this. So you can see this 7.5, it falls within the range from 2 to 27.
So you do. So Michael, you do 6 plus 9.
Yes, 6 plus 9, that is 15. Then divide by 2.
And then the answer you divide by 2.
Yes.
Oh.
So this one works when on the middle there are 2 numbers. But for our previous example, the middle only had 1 number, and you will pick that same number. Okay, so for these things that are here, okay, you can read through. I don't want to confuse you, but just to mention is that since we've said if the middle number is just 1, you pick that number. If the middle number there are 2, you add the 2 numbers, divide them by 2. So what this paragraph was trying to explain is if the total number is an odd number, the median will simply be one single value. But if the median is an even number, this is why you add and divide by 2. So what he meant here is this: you count the numbers here, 1, 2, 3, 4, 5, 6. 6 is an even number. So whenever the number of the data values is giving an even number, just know that the middle value, they are going to be 2 numbers. Okay, but if
sorry, just repeat again.
Okay,
Just repeat.
Okay, so I was saying that if you count the numbers here, 1, 2, 3, 4, 5, 6, and 6 is an even number, it means that for this one, the middle value, there will be two numbers. This is why we find the two numbers on the middle. Okay, so if the total numbers gives you a number which is an even number, on the middle there will be two values. Okay, but in this case, the previous example, we counted this to be 1, 2, 3, 4, 5. 5 is what? An odd number. So for an odd number, the middle value will simply be a single number. Okay, so the middle value will simply be a single number. Okay, so let's move forward. So we have this formula that we gave. So this formula, it doesn't really give us the median, it just tells us the position where the median is. Okay, so 0.5 tells us the position where the median is. Okay, let me see if there's an example. No, there's no example. Let me demonstrate how you use this formula. I'll use the first example. Okay, so this was our first example. So the question says find the median for the set of measurements. So this is the set of measurements. So the first thing you do, you arrange them from the lowest to the highest. So it's going to be 2, 5, 6, 9, 11. Okay, so once you do that, you can use this formula that the SAR gave, which is 0.5 n plus 1. So this one to tell you the position where the median is. So the positions are like this. So this one, it is the first position. Okay, this one is second, this one it is third, fourth, and fifth. So this formula will tell us simply the position. So how do you use it? You simply replace n. So n, what is n? N is the number when you count the numbers 1, 2, 3, 4, 5. So there are 5 of them. So this is what you put here. So it's going to be 0.5 brackets n. N is 5 because there are 5 numbers here. So 5 plus 1, this is going to be 0.5. 6 plus 5 plus 1 is 6. Then 0.5 times 6, it gives us 3. So it means the median is on the third position, and which is correct. We had found that the median is 6 on the third position. So this formula is simply used to find the position of the mean. Okay, I hope it's clear on this one. So I said this indicates the position of the of the median. Okay, so here now the median for a grouped data. So these two examples we were doing, we were calculating the median for data which is ungrouped. Okay, so So all this is ungrouped data, and the other example is ungrouped data. So now when calculating for median for grouped data, it is a bit difficult, and you'll see in this example it is not as easy as calculating for the median when the data is ungrouped. And the formula that is being used here is this formula. Median is equals to L. So I want us to understand L means the lower class boundary of the median. Okay, meaning the lower class boundary of the median. I'll explain it an example. C is the width of the what? The class interval. Fm is the frequency of the median class. N is the total frequency. CFB is the sum of frequencies for all classes before the median class. Okay, but to understand, break it down. Okay, so this is the formula. So this formula is used to calculate for median. Here you cannot arrange the numbers and then get the one in the middle for grouped data, because the data is grouped. So you can just like arrange them and then pick the value which is in the middle. Okay, for this particular one you have to use the formula. So let's say you are given okay, these are just instructions. So let's say you are given this sign. So the first thing, according to the instructions, construct a cumulative frequency. So for this example, the cumulative frequency has already been constructed. Okay? So the first step is already done here. Okay, the first step is already done. Step number 2, find the median class using this formula 0.5 n. Okay, 0.5 n. So how do we do that? So for the median class we use 0.5 n. So n is simply the sum of f. So what's the sum of f? Is 80. Okay, so you say 0.5 times 80, you get 40. So this 40 will help us to find the median class. So the median class, you check, okay, the numbers in the cumulative frequency. Which of these numbers here with the 40 with the 44 into? Okay, so 11 no, 31 no, because it is less than 14. So the number which is closer to 40 here will be the 61. Okay, to be the 61. So 61 is in this row, so meaning this is our median class. So our median class is 17 to 19. Okay, our median class is 17 to 19. That is where the 40 will fall into. So find the median class by locating in the cumulative frequency column, here in the cumulative frequency column. So if we found 40 will belong somewhere here in the 61. Okay, so this is how you pick the median class to be 17 to 19. Okay, I hope we are following. How is it going?
I'm a bit lost. You can repeat it.
Okay, so for this one, let me just repeat. Okay, so we are saying we are still on median, but for grouped data. Okay, median, but for grouped data. So this is the formula. Median is equals to lower class boundary, width of class interval, frequency of median class 0.5 n CFB. So the instructions are, you need to make a table, but in this case the table is already constructed for us. Okay, so we just go straight to step number 2, finding the median class. Okay, so in this example, if this question came maybe on a test or an exam, it will look just like this. So what you simply do, the first thing is to find the median class. So these are the classes. This is, let's say this is class A, this is class B, class C, class D, class F. So which among these will be our median class? Okay, which one among these will be our median class? That is step number 2. So the median class we don't know, so we use this formula 0.5 n. So n is the total frequency, the total in here. Okay, so we say 0.5 times n is 80, and then we get 40. See that, we get 40. So when we get 40, we then go in this frequency cumulative, we check the numbers where 40 will belong. So it will belong not here, this is 11 is less than 40, that one is less than 40, so 40 will fall somewhere in here, 61. So this 61 will now help us locate the median class. It is in C. You see 61 is in C. So our median class is 17 to 19. Okay, once you find the median class, that is when now you can use that formula. Okay, so the formula is this: median is equals to lower class boundary, width, okay, frequency mean, median class, and then sum of cumulative frequency. So L, how do we find L? Okay, L is the lower class boundary. So since our median class is 17 to 19, so the lower class boundary, which is L, we get it from the lower value of the class, which is 17. And how do you do that? You simply go back. So the number before 17 came in is what? 16.5. Okay, So the number before 17 is 16.5. That's when you reach 17. So the 16.5 is our lower class boundary. So you just get the lower class value, which is 17, go to the number before it, which is 16.5. Okay, so L is 16.5. okay, so this is what you got here, 16.5. but in some cases you can just pick the 17 itself. But if you want to be more thorough, you can go to the number before it. Okay, so C is the width. So the width is what? You look at the class again. The class is 17 to 19. So you count, okay, how many values are between 17 to 19. So it is 17 itself, then 18, then 19. So there are how many values? 3. So that is your class width. So that is the 3 that is here. Okay, that is the 3 that is there. So how do you find the C? You count how many numbers are between your median class. Okay, then that is the C. Then the frequency mean, you go back to your middle class, the median class. The median class is here. What is the frequency? It is 30. So that is the frequency mean. Frequency mean is what you put here. So you see 30 there. Okay. Then the median class value we already calculated, the 0.5n. What did we get? 0.5n, we got 40. Okay, this one we've already calculated it. You just replace it. It comes here. Okay, that's why there's a 40 here. Then lastly now, the sum of the cumulative frequency before the median class. So our median class is 17. So on the cumulative frequency, which one comes before it is 31. So pick the cumulative frequency before the median class cumulative frequency, which is 31, and that's what you put here. And then here the calculator will just help the calculations, and that's how we find the 17.4. Okay, how is it this one? Is it clear?
Which way when you go through again?
Or when you go through again, Okay.
Yeah.
Okay, so the following points to summarize. So the median is the most often used midpoint for a large set of measurement, and the good net is that, like we said, it's not affected by the outliers. Okay. Now the other central measure of tendency is the mode. The mode, you're looking at the common number. Okay. So mode is the common number, the number that is showing up more often. Okay, the one that is with the highest frequency. So for ungrouped data, let's see. So like here, this data is ungrouped. So you just look at which number appears the most. So you can see it is 9. 9 appears like 3 times. So 9 is the mode. Now for the mode, you can have more than one mode. So sometimes you can have two modes. Okay, if two numbers are appearing oftenly the same time, okay, for example here 4 appears 3 times, 7 also appears 3 times, so your modes will be 4 and what? 7, eh? Okay, your modes will be 4 and 7. So for the mode, you just look at the number that has the highest frequent, okay, the one that is frequent, the one that was recorded the most, that becomes your mode, eh? Okay, so this one, it is when you want to calculate the mode for when the data is grouped. Maybe we can do this one next time, eh? Yeah. Okay, yeah, okay, so that we also look at the normal distribution. Okay, so we can come and start next time, unless you have any questions.
I think we are going to ask when we go through. Just send the record when apa.
Okay, all right, I'll do that.